looking at this interactive 3D brain mapping visualizer.
All right, welcome. Today we're diving into some absolutely fascinating and, well, sometimes, frankly, unsettling material you've shared.
Yeah, it's quite the collection.
It's a set of notes and research all focused on, how glitches in the brain's hardware can manifest as really bizarre clinical symptoms.
Mm-hmm.
Our mission for this deep dive is pretty straightforward.
Mm.
We want to try and connect some truly strange experiences. People report things you might not even think are brain-related directly to specific areas up there. We'll use your source material as our guide.
And I think it's really key to say up front, while textbooks often give you these neat diagrams, brain area A causes symptom B.
Right, nice and clean.
Exactly. The reality, and your sources really hammer this home, is just far, far messier. So we're definitely going to spend a good chunk of time exploring the challenges, the complexities, the real problems in actually applying this knowledge. Because, yeah, the brain isn't always a simple machine. Totally. So think of this as understanding the mechanics, maybe the disturbing mechanics sometimes, behind what happens when the brain goes wrong. We'll look at those textbook links first, the ones from the source material.
The classic connections.
And then we'll kind of pick them apart a bit, just like your sources suggest we should. Okay, let's get into it.
Sounds good.
So the basic idea that the sources lay out is that the brain isn't just, one big lump. It's got specialized areas, each doing its own job.
Highly specialized, yeah.
And when activity goes wonky in one area, like during a seizure, for example, It doesn't just, shut down. It can actually produce very specific outputs, weird outputs that we experience as symptoms.
That's a great way to put it. The scenarios in the material often link these unusual symptoms directly to areas having abnormal electrical activity, like seizures.
Yeah.
It's almost like finding the specific wire that's short-circuiting.
And seeing what weird signal it blasts out.
Okay, let's jump into some of those strange perceptions and feelings your sources mention, like déjà vu, that really intense, unsettling feeling that you've experienced something totally new before.
Uh-huh. We've all had mild versions, maybe.
Right, but this is different. And sometimes the source even pairs that with involuntary stuff, like lip smacking. How on earth does the brain produce that combo?
Well, this is where it gets fascinating, because it's specific but also complex. The source links that intense déjà vu feeling directly to abnormal activity in the temporal lobe.
Okay.
This part of the brain is super involved in memory processing and emotion, too. So when seizure activity hits certain spots in the temporal lobe, like the inferior and middle temporal gyri mentioned,
Right.
it can basically hijack the brain's familiarity signal. It flips the switch that says you've been here before, even when you haven't, creates that really strong, false sense of recognition.
Wow. Okay. And the lip smacking.
Ah, the lip smacking. The source calls it an oro-elementary automatism. Bit of a mouthful.
Yeah, sounds it.
But it's basically one of those common, involuntary, repetitive movements you can see in temporal lobe seizures. It seems like the seizure activity grabs hold of these really basic, almost instinctual motor programs stored in that area, things related to eating, chewing, swallowing.
Primitive stuff?
Exactly, and it just plays them out automatically, involuntarily. So the brain's core wiring is sort of briefly misfiring in a very specific way.
Okay, so false familiarity and weird chewing, both potentially from the temporal lobe. Makes a spooky kind of sense. What about seeing things that aren't their visual hallucinations, and then that gets paired with the sudden, intense fear? They don't seem obviously connected.
No, not intuitively. And this starts to show us how different brain areas can get tangled up together. Your source links visual hallucinations, seeing lights, patterns, even complex scenes that aren't real to the occipital lobe.
Back of the head, the vision center.
Precisely. The visual processing hub. Dysfunction there, maybe from seizure activity in places like the middle occipital gyrus or other areas mentioned, directly messes with your visual input. It can literally create images from nothing.
Okay, that explains the seeing things part. But the fear.
Right, the sudden, overwhelming, unprovoked fear. The source attributes that very strongly to the amygdala.
The fear center.
Yeah, that little almond-shaped structure deep inside the temporal lobe, actually. It's the brain's main threat detector. When that gets abnormally stimulated, maybe by spreading seizure activity, it triggers pure, intense terror, completely out of context.
So the seizure could hit the visual area and the amygdala.
Exactly, or spread from one to the other very quickly. So you end up with this horrible experience. Seeing something terrifying that isn't real while also feeling absolutely gripped by inexplicable fear. It's a nasty combo born from specific brain spots misfiring together.
Yikes. Okay. Seeing scary things, feeling terrified. Occipital lobe, amygdala. Got it. What about hearing things? Auditory hallucination sounds, voices maybe with involuntary head turning.
Okay, so auditory hallucinations, hearing things that aren't there, the source linked that to the superior or upper part of the temporal lobe. That's where your primary auditorial cortex is located.
Makes sense. Hearing center.
Right. Abnormal activity there, maybe in the planum polaire or middle temporal gyrus for more complex processing, makes the brain think it's hearing sounds or voices.
And the head turning.
The head turning, what the source calls a aversive movement, that's a motor sign. It usually means the seizure activity isn't staying put.
It's spreading.
It's spreading. Often it's moving from where it started, maybe that temporal lobe spot causing the hallucination, across the brain to motor control areas on the opposite side of the contralateral hemisphere.
Okay.
And when it hits those specific areas controlling head and eye movement, it forces the head to turn, often towards or away from the side the seizure started on.
It really is like tracking a storm, moving through the brain's different neighborhoods. Okay, let's switch gears a bit. Movement and sensation symptoms, the brain directly messing with the body. Like muscles suddenly going rigid, then maybe the arms start jerking rhythmically. It sounds very physical.
It is, very much so. Your source connects that specific pattern, the initial stiffening, which is called the tonic phase, followed by the rhythmic jerking, the clonic phase, directly to the primary motor cortex.
The command center for movement.
Exactly. That crucial strip in the precentral gyrus. It sends out the signals for voluntary movement.
So what happens during a seizure there?
Well, the seizure activity is basically like chaotic, overwhelming noise flooding the command center. It sends out these haywire signals to the muscles. The initial massive discharge causes the muscles to contract all at once, really rigidly. That's the tonic part. Then, as the seizure activity fluctuates, becoming more rhythmic in its abnormal firing, the signals to the muscles become intermittent. That causes the muscles to repeatedly contract and relax the jerking or clonic phase. It's a direct physical manifestation of the electrical storm in the motor cortex.
Direct link.
Uh-huh.
Motor cortex chaos equals body spasms. Makes sense. What about problems with coordination? Feeling clumsy, unsteady, poor balance?
Coordination and balance. The main player here, according to the source, is the cerebellum.
Back and bottom of the brain.
That's the one. It's absolutely vital for fine-tuning our movements, keeping us upright, making sure everything is smooth and coordinated. Damage or dysfunction there leads to ataxia, that classic clumsiness, unsteadiness, difficulty with precise actions.
Okay.
Your source also adds that other areas chip in, particularly in the parietal lobe, like the superior parietal lobule. These parts help integrate sensory information, knowing where your limbs are in space, for instance.
Right, body awareness.
Which is information the cerebellum needs to guide movement accurately. So it's mainly the cerebellum, but it relies on input from these parietal areas too.
Cerebellum for balance, parietal for body sense.
Mm.
Got it. Now here's a really weird combo from the source. Suddenly losing vision and at the same time feeling numb down one side of the body. Those seem like totally separate issues. Why would they happen together?
Yeah, that is a strange one, and it really highlights how physically connected brain areas are and how seizures can spread along specific routes. So sudden vision loss, like we talked about, points to the visual pathways, probably the occipital lobe.
Okay, vision again.
Right, and the numbness or altered sensation that points to the parietal lobe, specifically the primary somatosensory cortex there. That's the brain's receiving station for touch, temperature, pain from the body.
So vision area, body feeling area, how do they connect?
The source suggests this combo can happen if seizure activity starts, say, in the visual part of the occipital lobe and then just spreads forwards. It moves right into the adjacent sensory processing areas in the parietal lobe.
Like wildfire jumping a boundary.
Kind of, yeah. The abnormal electrical storm just sweeps from the vision processing region straight into the touch processing region, causing both symptoms to appear almost simultaneously, even though they originate in different but neighboring functional sounds.
Wow. Okay.
Anyhow, we will continue this next time. Let me know if there's any questions. Yes, there's a human in the loop. Go check out the website, like, subscribe, share if you're with anyone who might be interested. You know what to do. And I'll address any further issues next time. See you in a bit. Bye.